Okay, basically we have this question and it's broken down into 3 parts in this video. We'll just only cover part A. So it's saying that give Q the point at a distance of 0.1 from P equals 4,5 in the direction of this vector. So the question is asking us to find point Q, hence give Q the point. Sometimes reading these questions can be very hard to decipher what they really want. So it's good to, break things down. Okay, so we are given this vector, negative I plus 3j. So this vector, right? This vector is a vector, and this vector is in this the vector that the point Q and P are in the direction of. Okay, they are in the direction of that, and they have a distance of 0.1, which is the magnitude of PQ or the magnitude of QP. And when we dot it with something, we have another vector, which I wrote here, vector W. So the V vector, we don't know we can get the length, but we want to normalize this vector to get the unit vector. So the unit vector, perhaps it's here, the unit vector on P to Q or Q to P. And once we normalize this vector to get the unit vector, we can use this unit vector. Okay, we can get this unit vector to find any other vector that is the scalar multiple of u, okay, of u. So once we take that, once we find the other vector, which we're trying to find w is the scalar multiple of u. That means that W is in the same direction as the unit vector, the unit vector is also in the same direction as V. But in order for us to find the vector W, we need to have some kind of standardized unit. So we have the standardized unit because the unit vector has a magnitude of 1. We use this 1 to get this times the scalar multiple to find the vector W. Hope that's clear because that can be very confusing. Okay, so once we normalize it, we have u, the unit vector. Alright, okay, so we have it here. This is the unit vector of in the direction that V is pointing at. And okay, so the next part is that we know what I just said was that this u, so we have the unit vector and we have the magnitude of QP or PQ. So from that, the QP or PQ is actually the scalar distance, the scalar multiple of some vector, and that some vector is actually the unit vector. Because when we dot the unit vector, dot the scalar, the magnitude of QP or PQ, we get another vector that's W, which is parallel to these two vectors, or just vector V, or that's parallel to vector V, or also parallel to the unit vector. But the unit vector is it's a very, very efficient, handy little tool for us to use. It's little because it only has a magnitude of 1. Keep the color. Nah. Okay. So we have that. So we have the unit vector and we dot it together, so we get the W. And W is actually the displacement vector from Q to P. Okay, So we have this W here, right? We have it here. But the question is asking us to find Q. How do we do that? We have two informations, two very valuable information now. We have the displacement vector from P to Q or Q to P. It's from P to Q. So, it's from Q to P, yeah. Okay, so P is the final point and Q is the initial point. So what I wrote here is that we have P, we know 4 or 5, and Q we don't know, so we set it to some variables X and Y. And then over here we have a green little side note for us to see. Because what we want to find is actually Q, right? But we have W and we have a vector, we have a point. How do we find the other point? So, for example, let's sidetrack a little bit. This will help us understand how we can find the point Q. So, for example, we're given 2 points, P and R, P at 3, 2 and R at 6, 5. And it says find the displacement vector. The displacement vector is actually the x in vector form. So we do final minus p. When we do final minus p, we have the displacement vector. Displacement vector. Okay, I'm just this is quite funny to me because okay, so this is good. This is quite funny and good. It's a good little exercise on the side for us to understand how we can actually find point Q. Okay, nevertheless, R to P, because final minus initial, we have this vector. Okay, so we have this, right? 6 minus 3, 5 minus 2 will give us J. And then we know that the PQ will be 3I plus 3J, because 5 minus 2 will give us 3J, 6 minus 3 will give us 3I. So I wrote it in this form for us to compare to how we can find X and Y, which is the point Q. So W, we can write it on this side because W is like R and P in this instance, and then we have 4, which is R in this case, 4 minus, so it's from final minus initial, 4 minus X, 5 minus Y will give us the J vector in the Y direction. And then, so from this, what do we do with this right now? Because this is kind of odd, but if we think about it, 4 minus some number, 4 minus some number has to give us 3.031. Well, let's look back, refer back to this. 6 minus 3 minus what? Okay, 6 minus 3 is 3. And then if we put in, and then we have to say that, 6 minus what number will give us 3? Can it be 4? No, 6 minus 4 is 2. So it has to be 3 here. So another instance here, 5 minus 2 will give us 3. So 3 plus what number? 3 plus some number will give us 5, right? Because 5 minus 2 will give us 3. So when we say that we have this number, which is 0.048, right? Similar to the 3J here, up here. So it's saying that 0.048 plus Y has to give us 5, right? So basically all we have to do is the next two steps here. 4 minus the number will give us 3.96. 5 minus the 0.0948 will give us 4.905, because when 4.905 plus 0.0948 will give us approximately 5, And similar to this case, 3.96 plus 0.031 will approximately give us 4 if you want to be exact. It's a pretty long decimals, but if you want to be exact, you can write down all the decimals you want, and we get this number. So the point Q is actually 3.96 comma 4.1.